Hey everybody, welcome back. This is a video to go over the Unit 3A practice test. So Unit 3A is bonding, ionic, and metallic. So let's jump right into this. Number one, what occurs when potassium reacts with chlorine to form potassium chloride? Now, when we're talking about types of bonds, it matters what the elements are, how they're classified. So potassium is a metal, chlorine is a nonmetal. Whenever you have a metal and a nonmetal, that is an ionic bond. Now in ionic bonds, electrons are transferred from the metal to the nonmetal. That's the definition of an ionic bond. So looking at our answer choices, we can go get rid of A and B because they talk about being shared. And then the second half, ionic versus covalent. At this point in time, we've only ever gone over ionic bonds, but it's metal and nonmetal, so it is C. Number two says which element reacts with oxygen to form ionic bonds. Again, ionic, you want your metal and your nonmetal. Oxygen is a nonmetal, so we need an answer choice that is a metal. These are nonmetals, hydrogen and nitrogen, can't be them. Chlorine is a nonmetal, but calcium is a metal, so it must be A. Number three, which substance contains bonds that involves the transfer of electrons from one to the other? Transfer of electrons is ionic, and ionic again is a metal plus a nonmetal. So we have to look for an answer choice that has a metal and a nonmetal. Two chlorines, you have two nonmetals. K, potassium is a metal, Br is a nonmetal. That should be your answer, let's just double check. N, nitrogen is a nonmetal, hydrogen is a nonmetal, and both carbon and oxygen are both nonmetals. So it means our answer is C, potassium bromide, or KBr. Number four, which type of bond results when one or more valence electrons are transferred? So again, we are focusing on the transfer of electrons, and that is our ionic bond. Again, if you forget that, of the four answer choices, we've only ever talked about ionic bonds. But again, transfer of electrons is ionic. Okay, number five. Number five says the particle diagram below represents a solid sample of silver. Which type of bonding is present when the valence electrons move within the sample? So Ag is a metal, and a bond between metals is metallic bonding. But what's fancy here is these electrons, they're able to kind of flow freely. We call this the C of mobile electrons. And so that allows metals to be good conductors at literally any phase they are in, which generally they're solids, because the electrons can move freely. That is a characteristic of the metals. Which brings us to number six, a solid sample is an excellent conductor of electricity. So a solid is a good conductor, which means the chemical bonds in this substance must be. Now we have learned that ionic is a conductor in the aqueous or liquid state only. It is not a conductor as a solid. So it can't be A, it can't be B. And now we have metallic, and if we break down C and D, valence electrons are stationary or mobile, it is D. It's all about getting electrons to move. If electrons and negatively charged ions can flow freely, that means electricity can be conducted. Again, with your metal sample, you have, just like this diagram up above says, the electrons can move freely, so any phase of matter, generally solids for metals, can conduct electricity. But in ionic compounds, when an ionic compound is a solid, everything is stuck together, nothing can move. But once you throw that sample in water and it dissociates into its ions, the ions can swim around in the water and conduct electricity. Okay, number seven, which Lewis electron dot diagram represents the bonding in potassium iodide. So potassium is K, grab a different color, and iodine is I with that -1 charge. If we do some crisscrossing, we get our formula as K with a 1 from I, and I with the 1 from K. Now, with that, that tells us we need one K and one I in our picture. Now, all of our pictures, or our answer choices, have one K and one I. But K has that +1 charge. And a +1 charge means you lose one valence electron. So if a potassium atom has one valence electron, when you lose it, you draw nothing. And to represent to the world that you know what you're doing, you draw brackets and that +1 charge. So our K needs to look like this. Now, sometimes the Regents doesn't draw brackets around the positive ion. Not really sure why they don't do that, but they don't. So let's make sure we have something that looks like our I. Now, I has that -1 charge, which means it gained one electron. So an iodine atom has 7 valence electrons. When it gains one to fulfill that valence shell, it now has 8. 3, 4, 5, 6, 7, 8. And to tell the world that this is not a mistake, you know what you're doing, brackets and that -1 charge. Now, in ionic bonds, you got a positive thing, you got a negative thing, you stick them together because opposites attract. Now, choice A is the one that shows that the best. At this point, we at least need brackets in our stuff, and then make sure the metal is your positive with no dots, and your nonmetal is negative with all 8 dots. Okay. Number 8 is very similar, calcium oxide. Our formula for calcium oxide is crisscross Ca2O2, which is simplified to CaO. So 1 calcium, 1 oxygen. Remember, calcium again is our metal, so it has nothing drawn, and it's brackets and the charge. Oxygen is your nonmetal. Nonmetal ions have all 8 dots, brackets, and the negative charge. Again, sometimes the Regent doesn't draw brackets around the positive ion, but D is the best answer choice that we have. Okay. Number 9 says, which is the Lewis electron dot diagram for the sulfur, or S2 minus ion. So sulfur normally has 6 valence electrons, and a -2 sign means it gains 2 electrons. So when you gain 2 electrons, you have 8. Now, this just looks like you don't know what you're doing, so you have the wrong number, but to let the world say, hey, I know what I'm doing, you add your brackets, and your -2 charge, which makes it D. Again, a good shortcut for dot diagrams for ions. All of the metals, whatever, if it's a metal, you're going to draw no dots, brackets, and whatever the charge is. And non-metals, you're going to draw all 8 dots, brackets, and whatever the charge is. Okay. Number 10, which Lewis dot diagram is drawn correctly for the atom it represents. So remember, again, these show the valence electrons. So you got to go back to your reference table. Nitrogen should have 5 valence electrons. Fluorine should have 7 valence electrons. Oxygen should have 6 valence electrons, and neon should have 8. So now that you know what they should have, let's see what they do. This shows nitrogen having 4, can't be this. B shows fluorine having 8, we know it needs 7. C, oxygen should have 6, but 7 are drawn. But D, neon should have 8, and 8 are drawn, so it is D. Moving on along, number 11, what is the net charge of the monoatomic ion that has 15 protons and 16 neutrons and 18 electrons? Remember, protons are positive, neutrons are neutral, and electrons are negative. So we don't care about the neutrons. If we have 15 positive things, which are protons, and 18 negative things, which are electrons, you have 3 more electrons, which means you're going to have a -3 charge. If you write 3 negative, or 3 minus, or -3, that's the same thing, okay? So if you had more protons, it would be positive. If you had more electrons, it is negative. So you could essentially draw 15 pluses, and all of the minuses, you have extra ones, which makes it the negative charge. Moving along, when an F atom becomes an F ion. So F has 7 valence electrons. When it becomes an ion, to fulfill that octet rule, it is going to have all 8 and that charge. So it's going to gain an electron. Now, if you change the protons, remember back to our periodic table unit, if you change the protons, you are changing the element, not what we're doing. When we're talking about ions, it's just talking about what happens to electrons. Fluorine is a nonmetal, it becomes negative. You only become negative by gaining more electrons. Okay. Number 13, going back to definition questions, an ionic bond can be formed when one or more electrons. We know an ionic bond, electrons are transferred, so it can't be A or B. And then if we look at choice C, transferred from the nucleus or transferred from the valence shell, we know from unit 1, electrons live in the valence shell, and that's where they are transferred from. In the nucleus, you have your protons and your neutrons. Okay, number 14, what changes occur when a cadmium atom becomes a cadmium ion? So a +2 charge means you are gaining 2 electrons. So gain, gain, lose, lose. We can get rid of C and D. And now we're talking about the radius increasing or decreasing. So when you lose electrons, you are going to become smaller. When you gain electrons, you're going to become bigger. So we can even see that if we look at your periodic table, CD has the electron configuration 2-8-18-18-2. Now, when it loses 2, and this has 1, 2, 3, 4, 5 shells. Now, when you lose an electron, when you become an ion and you're a metal and you're losing electrons, you're losing that shell. So now it has 4 shells. And so your CD ion would be 2, 8, 18. And because of other stuff, becomes simpler, becomes more complicated. But you have now 1 less shell. So when you lose electrons, you are going to sorry. Okay, let's look at question number 14. What changes occur as a cadmium atom becomes a cadmium ion? So a +2 charge means you are losing 2 electrons. So gain, gain, lose, lose. We can get rid of A, we can get rid of B. Now, when you are losing electrons, you're becoming smaller because you're losing that valence shell, the radius decreases. So again, metals will become positive ions because they lose electrons and they are getting smaller. And if we think about it, CD has the electron configuration 2, 8, 18, 18, 2. When you lose those 2 electrons, that shell disappears and it becomes smaller. Okay, 15 says which electron configuration is correct for a sodium ion. So if you look at a sodium atom on our periodic table, that gives us the configuration 2-8-1. But as an ion, it is going to lose that last shell, making it 2-8. Again, an ion will have the electron configuration of a noble gas. Okay, number 16. When an atom loses an electron, the atom becomes, so we're losing an electron. When you lose negative stuff, you become positive. So we can get rid of C and D. And electrons, even though we ignore the mass, they do have mass. So if you lose an electron, you're positive, and you lose a small amount of mass. You lose a little bit of mass and you get smaller. Okay. Number 17, which species has the same electron configuration as a Cl- ion? So chlorine on its own has the configuration 2-8-7. If we're going to do Cl-, that minus means you're gaining electrons, so it's 2-8-8. Now, if we look at our electron configurations for other things, now you're looking for in your periodic table something that has 2-8-8, which is argon. Okay. Number 18 rather, a hard substance that has a high melting point and a poor conductor of electricity in the solid fate. So high melting point, poor conductor of electricity in the solid fate, because metals are conductive in the solid state. Ionics are not. So we're looking for something that is ionic, again, which is a metal and a nonmetal, which is answer choice C. 19 talks about, which is composed of a regular geometric pattern. So one that talks about solids, but it talks about ionic solids. So ionic compounds are C and D, but again, it has to be a solid because solids give you that crystalline structure, making it C. Number 20, which substance dissolves in pure water and produces a solution that is a good conductor of electricity. So now we've dissolved it, it's in water. Again, this is ionic. You want that metal and your non-metal, making it choice A. So there's only a handful of concepts that you really need to know for this unit. Ionic bonds, metal, non-metal, electrons are transferred from metal to non-metal. Metals form positive ions. Because they lose electrons, they get smaller. Non-metals form negative ions. Because they gain electrons, they get bigger. That's honestly essentially it. Ionic compounds will conduct electricity in the aqueous state or the liquid state, but not as a solid because there is no free-flowing ions. So on to the short answer real quick. Number 21, explain in terms of element classification why silver chloride is an ionic compound. Silver is a metal. Chlorine, just do the symbol, is a nonmetal. And so when asked for element classifications, how are elements classified? They are classified as metals, nonmetals, or metalloids. So silver is a metal, chlorine is a nonmetal, and an ionic bond happen between metal and nonmetal. So you got to state that silver is a metal and chlorine is a nonmetal, and that ionic bonds happen between metals and nonmetals. Number 22, explain in terms of electrons why this is ionic. Now, if you wrote sodium is a metal, chlorine is a nonmetal, that is an accurate statement, but it would be marked wrong because it's not in terms of electrons. Electrons are transferred from Na to Cl. That's what makes it ionic. It's the transfer of electrons. Number 23, identify the type of bond formed when potassium, which is a metal, react with bromine, which is a nonmetal, to form a salt. Now, if it does identify, literally write 1-2 words. We don't want to read essays. When you have a metal and a nonmetal, that is an ionic bond. Literally 2 words. If you just wrote ionic, that would have been perfectly fine as well. Number 24 says draw a Lewis dot diagram for a bromine ion, and it says Br minus in case you can't quite see it. So again, that minus is this -1, which means you gain an electron. So bromine normally, as an atom, has 7 valent electrons, but a bromine ion has an extra one. You have your brackets and you have your charge. And that is it. And then our last question, it says state in terms of electrons why the radius of Be2 plus ion is smaller than the radius of the Be atom. So Be plus 2 is smaller because it lost 2 valence electrons and has less electron shells. So we've talked about electrons multiple times in our answer. It lost 2 valent electrons and it lost that electron shell. But as long as you're talking about, hey, it's losing electrons, that is good. Now, that is it for this practice test review. Hopefully that helped you. If things were gone over a little bit quickly, by all means, go backwards, rewatch it. And you can even go back to the YouTube channel where each topic is covered in more detail. Hope this helped. Happy studying. Bye.